They told you Jupiter is just the biggest planet, but they never told you it bends the sun, swallows comets, and hides storms older than human civilization. A planet so massive, it doesn't orbit the sun, it dances with it. With rings you've never seen, radiation fields deadlier than Chernobyl, and clouds that change like alien skin. This isn't just a gas giant, it's a cosmic guardian, a ticking time bomb, and a mystery we've only just begun to understand. This is the Jupiter they never taught you about. Jupiter doesn't just sit in the solar system, it anchors it. It's the fifth planet from the Sun, floating far beyond Earth, just beyond the edge of the asteroid belt. It's so far away, light from the Sun takes over 43 minutes to reach it. On average, Jupiter is about 778 million kilometers from the Sun. That's more than 5 times the distance from Earth. And because it's so far, a single year on Jupiter lasts nearly 12 Earth years. But while it may orbit slowly, Jupiter spins fast. And unlike Earth, which tilts over 23 degrees, giving us seasons, Jupiter barely tilts at all, just 3 degrees. This means it has no real seasons. Its weather? Permanent, relentless, timeless. Jupiter is a giant in every way. Over 1,300 Earths could fit inside its volume. It's not just the biggest planet. We're talking about a world so vast, it's almost a solar system of its own. But here's the twist. Jupiter isn't just big, it's heavy. So heavy, in fact, that it can do something that no other planet can. And that changes everything. Jupiter isn't just big, it's heavy. So heavy, in fact, that it doesn't orbit the Sun the way other planets do. Let me explain. Jupiter holds just 0.1% of the Sun's mass. That may sound small, until you realize the Sun holds 99.86% of all the mass in the solar system. That means Jupiter contains most of everything else. And its gravitational pull is so intense, it actually shifts the Sun's position. You heard that right. The center of gravity between the Sun and Jupiter, the barycenter, doesn't sit inside the Sun. It hovers just above its surface in empty space. Which means, technically, the Sun and Jupiter are orbiting each other. Let that sink in. One planet, pulling the star that gave us life. That's the kind of power Jupiter holds. And that power doesn't stop with the Sun. It warps space. It twists orbits. And it might be influencing more than we realize. Because next, we're going to talk about how Jupiter's size hides a surprising truth. It may be the biggest planet, but it's not the densest. We've established that Jupiter is the biggest planet, but here's the twist. It's not the densest. Far from it. Its size comes from its massive volume. Huge, yes, but it's mostly made of lightweight gases like hydrogen and helium. If you took Neptune and made it the same size as Jupiter, Neptune would actually outweigh it. And if Earth were somehow scaled up to Jupiter's size, it would be 4 times heavier. So what does this mean? It means Jupiter is like a giant balloon. Massive, but not packed. Its outer layers are thick and sprawling, but the deeper you go, the more intense the pressure becomes. Its mass is what gives it strength, but it's not compact. It doesn't crush itself into a dense core the way rocky planets do. But this lighter composition gives Jupiter a strange advantage, because what it lacks in density, it more than makes up for in influence, and that influence stretches far beyond its orbit. In fact, Jupiter's gravity may be shaping the fate of every planet in the solar system, including ours. Let's explore that next. Jupiter's gravity doesn't just control its own moons, it whispers to the entire solar system. Every planet, yes, even Earth, feels its tug. Its influence is so massive, it's believed to be slowly altering the orbit of Mercury, our closest planet to the Sun. Some simulations even predict that millions of years from now, Mercury could be flung into the Sun or ejected into deep space. But Jupiter isn't just a disruptor, it's also a defender. It acts like a cosmic bouncer, grabbing, deflecting, or swallowing objects that could otherwise threaten Earth. Long-period comets, drifting in from the edge of the solar system, often meet their end in Jupiter's gravity well. Some scientists believe we owe our very existence to this. Without Jupiter, Earth may have been bombarded by extinction-level impacts long before life had a chance to evolve. It protects us, but in its own cold, indifferent way, like a silent guardian who doesn't know we're even here. But while its influence is immense, Jupiter is also visible, strikingly so. You've probably seen it with your own eyes, without ever realizing what you were looking at. You don't need a telescope to see Jupiter. Most nights you can spot it with your own eyes. Bright, steady, and unmistakable. In fact, after the Moon and Venus, Jupiter is the third brightest object in the night sky. At its peak, it shines with a magnitude of -2.94. That's bright enough to cast shadows here on Earth. Think about that. A planet 5 times farther from the Sun than we are, shining so brightly it can challenge your porch light. And if you do have a telescope, even a small one, you'll be rewarded. From your backyard, you can see its iconic bands, its storms, and even its 4 largest moons, Io, Europa, Ganymede, and Callisto, dancing around it in real time, just like Galileo did over 400 years ago. But Jupiter's beauty hides something deeper. Those mesmerizing patterns across its face aren't just decoration. They're the result of something far more violent and complex, an atmosphere in constant motion. And the deeper we look, the stranger it gets. Jupiter's atmosphere is a masterpiece of chaos. Bands of color wrap around the planet like stripes on a spinning marble. Brown, white, orange, even red. But what are we actually looking at? These bands are massive jet streams moving in opposite directions created by the planet's rapid rotation. The upper layer is made mostly of ammonia crystals, forming clouds just 50 kilometers thick. But the real secret lies in what rises from beneath. Deep inside Jupiter, strange chemical compounds called chromophores are brought up through convection. When they reach the upper atmosphere, they react with ultraviolet sunlight, creating Jupiter's vivid, shifting palette. No one knows exactly what these chromophores are. Some theories point to complex organic molecules, others to sulfur compounds. Whatever they are, they give Jupiter a living, breathing appearance. But this beauty isn't gentle. It's the face of an atmosphere locked in eternal turbulence. And where these bands collide, the most powerful storms in the solar system are born. One storm in particular has become a legend, and it's still spinning today. There's a storm on Jupiter, so large it could swallow Earth twice and still have room to spare. It's called the Great Red Spot, and it's not just a weather system, it's a planetary icon. This colossal vortex has been raging for over 350 years, and maybe much longer. It was first observed in the late 1600s, and since then, it's never truly stopped. Winds reach speeds of over 400 kilometers per hour, spinning in a massive counterclockwise spiral. But even with centuries of observation, its true nature remains a mystery. Why is it red? Why has it lasted so long? And why is it shrinking? Its color has shifted over time, from deep brick red to pale beige. The most accepted theory? Sunlight breaking down chemicals high in the atmosphere, giving it that eerie hue. But even now, no one knows for sure. What we do know is that it floats higher than the surrounding clouds, catching more sunlight and radiating power. And here's the thing. it's not alone. Because Jupiter doesn't host just one massive storm, it hosts many. Some are forming, some are dying, and some are beginning to challenge the Great Red Spot itself. While the Great Red Spot gets all the fame, it's just one piece of Jupiter's stormy empire. In the late 1990s, 3 smaller storms collided and merged into a single swirling vortex, now known as Red Spot Jr. It's about half the size of the Great Red Spot, but no less fierce. And unlike others that vanish into the chaos, Red Spot Jr. has endured, growing, darkening. At one point, it even turned the same ominous red as its larger sibling. These aren't rare events. Jupiter's atmosphere is filled with cyclones, anticyclones, and chaotic swirls the size of continents. Storms appear and disappear, clash and combine like titans battling across an alien sky. One storm was bold enough to cross directly through the Great Red Spot and survived. Some scientists believe these interactions could eventually end the Great Red Spot or create something even more powerful. Because on Jupiter, nothing is permanent. Only the chaos is. But what drives this madness? What powers these storms from within? To understand that, we need to go deeper. What lies beneath Jupiter's swirling clouds? The deeper we go, the stranger it gets. At first, the atmosphere is familiar, hydrogen and helium gases, similar to the Sun. But as pressure increases, those gases are crushed into something entirely different. Go down far enough, and hydrogen, normally the lightest, most basic element in the universe, turns liquid. Keep going, and that liquid hydrogen becomes metallic. Yes, metallic hydrogen. A state of matter that doesn't naturally exist on Earth. It conducts electricity, generates Jupiter's magnetic field, and behaves like a metal made from a gas. And at the core, no one knows for sure. Some models suggest a dense, icy, or rocky heart. Others think it might be a fuzzy fluid region, blurred by unimaginable pressure and heat. The truth is, we've never seen it. We can't recreate those conditions on Earth. It's a world hidden within a world. And it's this exotic interior that helps explain something else. Why Jupiter spins so fast, but still is not a star. Jupiter spins fast, really fast. It completes a full rotation in just 10 hours, the fastest of any planet in our solar system. But here's the twist. Jupiter isn't solid. Its equator rotates faster than its poles, creating powerful jet streams and dramatic banding across its atmosphere. This differential rotation is what gives Jupiter those hypnotic stripes and fuels many of its storms. As a child, you might have wondered, if Jupiter is so massive and mostly made of hydrogen, why isn't it a star? After all, hydrogen is what fuels the sun. But here's the truth. Stars shine because of nuclear fusion, a process that only starts when enough mass creates enough pressure at the core. Jupiter is big, but it's not big enough. It would need to be about 75 times more massive to ignite. If it had just a bit more mass, it would have become a brown dwarf, a failed star. Instead, Jupiter is something else entirely. A superplanet, a near star, a cosmic almost. But even as it failed to become a sun, it gained something Saturn never did. Rings. Yes, Jupiter has rings, but blink and you might miss them. Unlike Saturn's dazzling halos, Jupiter's rings are faint, thin, and made mostly of dust. They weren't discovered until 1979, when NASA's Voyager 1 spacecraft flew past and caught them. Barely. In silhouette. There are 4 rings in total. The brightest is called the main ring, stretching about 6,500 kilometers wide. And then there's Metis Notch, a mysterious dip in the main ring caused by one of Jupiter's inner moons, Metis. It's like a scratch on an old vinyl record hidden in the darkness. These rings aren't made of ice like Saturn's. Instead, they're likely formed of micrometeorite impacts on Jupiter's small inner moons, kicking up clouds of fine debris. They may not be showy, but they're proof of Jupiter's complexity. Even its shadows tell stories. But Jupiter's most powerful present isn't in its rings, or its storms. It's in the invisible field that surrounds it, a force so strong it shapes space itself. Jupiter isn't just big, it's magnetically monstrous. Its magnetosphere, the region controlled by its magnetic field, is the largest of any planet in the solar system. It stretches over 7 million kilometers, engulfing even some of its moons. To put that in perspective, it would appear twice the size of the full moon in our sky if we could see it from Earth. And it's not just big, it's brutal. Generated by its layer of metallic hydrogen, Jupiter's magnetic field is 14 times stronger than Earth's. This traps high-energy particles in deadly radiation belts, so intense they've crippled spacecraft and would kill a human in hours. Its inner moon, Io, orbits right through this deadly zone, receiving up to 3,600 rems of radiation per day, enough to be lethal in 4 hours. But here's the twist. That same magnetosphere also protects Jupiter's largest moons from solar wind, acting like a planetary force field. A deadly paradox, destroyer and protector, all in one. And those moons? They're not just lifeless rocks. Some of them may hold oceans, volcanoes, even the building blocks of life. Because Jupiter's most fascinating secrets may not be on the planet itself. They might be orbiting it. Jupiter doesn't just have moons, it has a mini solar system of its own. At last count, 67 natural satellites ranging from tiny space rocks to worlds larger than Mercury. But 4 of them stand out. They're called Galilean moons: Io, Europa, Ganymede, and Callisto, discovered by Galileo in 1610. And each one is a story waiting to be told. Io is the most volcanically active body in the solar system. Its surface is constantly erupting, reshaped by lava and sulfur, a world in perpetual turmoil. Europa is smooth, icy, and quiet on the surface, but beneath that frozen crust, there may be a vast subsurface ocean, saltwater, warm, and potentially capable of supporting life. Ganymede is the largest moon in the solar system, even bigger than Mercury. It's the only moon known to have its own magnetic field. And Callisto? Ancient, cratered, and untouched for billions of years, a planetary time capsule. These aren't just moons, they're worlds, and they remind us that Jupiter's influence goes far beyond storms and gravity, because even in its orbit, it may be harboring life. But Jupiter's greatest act might be what it stopped from happening. In July 1994, something incredible happened. A shattered comet, Shoemaker-Levy 9, slammed into Jupiter at over 200,000 kilometers per hour. The explosions were so massive, they left scars bigger than Earth visible for months. And just like that, Jupiter did what it's been doing for billions of years. It took the hit, so we didn't have to. Time and time again, Jupiter's massive gravity pulls in rogue asteroids, comets, and icy bodies. It clears the path, shielding the inner solar system, Earth included, from devastation. It's our cosmic bouncer, standing guard at the edge of the planetary neighborhood. Without it, there's a chance life on Earth might have been wiped out long before it ever began. But here's the real question. Is Jupiter just a lucky accident? Or part of a cosmic system far more deliberate than we realize? Because when you look at its size, its timing, its perfect position, it starts to feel like Jupiter isn't just protecting us. It might have been the reason we got here at all. Jupiter isn't just the largest planet in our solar system. It's the silent architect of order, a destroyer of threats, a cradle for moons that may one day reveal life. And yet, we've only scratched the surface. Because somewhere out there, floating in the shadows of our cosmic backyard, there's another secret waiting to be uncovered. Click the next video and prepare to have your mind blown.